Okay, so now that I've given you guys a couple different ways to find derivatives using some different formulas for derivatives, I'm going to give you one additional alternate form for the derivative if you're given an x value. So this is the original definition I gave you, where you can take the limit as, and that should be here, you can take the limit as change of x approaches 0 for f of c plus change of x minus f of x all over change of x. We also talked about in class how you can use just the x plus change of x, and this actually should be c, f of c, sorry about that. We also talked about how in class you can do f of x plus change of x minus f of x all over change of x, and then plug c in at the end. So either of those work. So another way to find the derivative when x is c, so that's the symbol there, is to say I can just take the limit of f of x minus f of c all over x of x minus c as x approaches c. So the reason I can do this is because if you think about what this meaning is, c plus change of x, well, aren't we saying that that change of x stands for approaching 0, we're saying that stands for a c value getting closer and closer to x. So here's x. Here's some c that I'm looking at. Remember, originally this came from looking at having 2 points and using a secant line. But as change of x approaches 0 and gets smaller and smaller, we say the c becomes x, and therefore we are able to determine the slope of a line at one single point. Well, if this is approaching 0, couldn't we just say that c is approaching x, and that c plus change of x as change of x is 0 is just f of x? That is where this formula comes from. Since x is approaching c as change of x approaches 0, we can replace c plus change of x by x and change of x approaching 0 to x approaching c, being able to use this formula here. So looking at one example of how this formula works, if I want to find the derivative at 2 for my function f of x equals x times x minus 1, I'm going to go ahead and use my alternate definition and say the limit as x approaches 2 of f of x minus f of 2 all over x minus 2. Well, f of 2 I can find by plugging 2 into my function here, which gives me 2 times 2 minus 1, which is 2 times 1, or 2. And I get the limit. As x approaches 2, I'm also at the same time going to go ahead and FOIL that out. X squared minus x minus 2. X minus 2. From here I can find the limit by factoring the top. I get the limit as x approaches 2 of x plus 2, x minus 2 times x plus 1 all over x minus 2. Well, the x minus 2 cancels out, which allows me to use direct substitution, and I get the limit as x approaches 2 of x plus 1, which is just 3. So another option to using this more formal definition, so using this alternate definition here.